Okay. Let's look at 2.3. Ready? So here I don't know why it comes out like that, but we are evaluating limits analytically. So basically, that means use instead of using graphs or plugging in numbers really close and kind of figuring it out on both directions, we are going to use algebra or other techniques to figure it out. So this is 2.3. So that page. Evaluating. I think I need a new notebook. Limits. Analytically. Okay. Number one, remember I told you the first thing you should try is just plug it in and see what happens. What this is saying, let me switch back after I write this down. As x approaches -7. All right, so all that means is what is the y value doing as the x approaches -7 from both directions? So, but if you can plug it in, we'll go ahead, right?
Professor, it's too small to see.
Okay. Is it blurry or what do you mean? No, okay. Okay.
Looks good for me.
All right, let me know. We'll try to write better too. So all this means is plug it in. So what is -7 cubed? I don't know what that is. It's gonna be a negative, that's for sure. 7 times 49. 7 times 49, what is that? You guys get 343.
Yes.
Right? So since we were able to plug it in, that's your limit. If you can't plug it in, then we got to see if there's any algebra tricks that we can do to make it happen. Okay. So the first few are just kind of are going to be just like that. Just plug it in. Now, number two, you see how if you plug in 1, you're going to get 1 over 1 squared plus 8, which is equal to 1 over 9, right? Do you agree? So there's no issues here. So that would just be the answer. Okay. So just keep trying it until you get an issue. Let's look at one that it's going to be a problem. Okay. Here they're just using functional notation. Let me check it out. Let the limit f go to 5, limit of f. So that means you just plug in the 5 right there. Plug in the 2 to here. Right? Or sorry. Right there. Now, this guy, do you remember how to deal with composite functions?
Yeah, I guess.
Yeah. Oop, freezing up over here. Yeah, pretty much. Exactly. Function within a function, right? So f is inside g, and g is this guy. So what does g do? G squares whatever you plug in. So if I plug in this, which is f, it's going to square it, right? So that would be simply,
X plus 9 squared.
yeah. So what does this do as it goes to 5? Well, that means you plug in 5, right? So 5 plus 9 squared. That answer will go here. Okay. Is there any question on that? I don't think it's not too bad, right? Okay, let's do 5 on the paper. Five says find the limit of the function if it exists. You should see that you're going to have a division by 0, right? As x goes to -6, you have x plus 6. Up here we have x squared minus 36. So right away, what do you see down here if you plug in a -6?
You get a 0.
Yeah, it's a problem, right?
Yeah.
Okay. So this is when we got to do some algebra to help us out. Okay, let's see if I can make that a little less blurry. So what we can do, remember the notation, you're supposed to write the limit notation all the way until you plug it in. So if I haven't plugged it in, you got to keep writing it. So right here, this is the factorization of the top, right? It's a difference of squares. What do you notice?
You can cancel out the x plus 6 and x plus 6.
So now that it's canceled, we can take the limit of x minus 6, right? What is it going
Yeah.
to be? Right? So when this happens, this is considered to be a removable discontinuity. So it's kind of like we're filling the hole in the graph. So if we were to graph it, oops, sorry, I'm like freezing up over here. Need to build a new computer. This thing's trash. All right. So -6 was the issue, right? Right here. Where is it? Yeah, it's still undefined right there. Easier if we do it this way. That way I can force an intersection. So on the blue graph, uh, it's undefined, right? But when we canceled the values, we were able to fill this hole. We removed the point of discontinuity, which we'll talk about more later, what that means. But we use algebra to help us out. So that's what they mean by analytical approach. Is factor, cancel your terms. The simpler function right here is the one that you guys told me, x minus 6. And the limit was negative 12, right? That's it. Is there any questions on what they want you to do? How to do it?
How did we get -12 for the limit?
So once we were ready, right?
Yeah.
The cancel, just plug it into the x. So negative 6 minus 6
Mm-hmm.
is going to be negative 12.
Oh, okay. So we just plug in -6, right?
Yeah, this is the first thing you should try. Just plug it in and
Okay.
see if you can. If you
Oh.
notice division by 0, then you got to try something else first. In
Okay.
this case, we had to do algebra first, and then plug it in. Over here,
So,
there was no.
okay. So we get x minus 6 as the result of doing the simplification. And
Mhm.
then the limit x equals -6, we plug in the -6 to the x minus 6, right?
Yeah, just anywhere you have
Oh.
an x, right?
Thank you.
So number one, all you did was we just had that one term, so that was it. So number 6 would be the same deal. Factor the top using the difference of cubes formula. This will cancel, and then you plug in 1. Number 7 wants you to show every single step. Show the factorization. The bottom is a difference of squares, right? So this would be x minus 7, x plus 7. These would cancel, leaving you with just the x plus 7. And then they want you to just put in the result, which is this guy, right? Now this one, no, it's just forcing you to go step by step to solve your answer. There's a bunch of proofs in the book that proves that all this works, but they can take quite a bit of time. But they are fun. Number 8. Let's see here. Same type of a deal. Before we move on, so there's another technique. So the first technique was just factoring and canceling the terms. Do you have any questions on that idea? Okay. The next technique is the conjugate pairs. You see how we have a square root? And on the bottom, you have the x minus 28. So we take advantage of the square root and the conjugate pair to cancel this term. You write number 9 down. The limit as x approaches 28, you should see right away that you can't plug it in, right? Did everyone see that? So the technique you use for these, whenever you see a square root plus something or minus something, you should multiply by the conjugate. conjugate of square root of x plus 8 minus 6 is square root of x plus 8 plus 6. So it's the same deal, just put a plus. Do you remember what conjugate means?
Yes.
Then multiply this on top and bottom, and you force a difference of squares, which should cancel this term eventually. Okay, this is what we're going to do. Okay. Top and bottom. Otherwise, we won't have equality anymore.
I thought we are conjugating the x minus 28.
No, we want to do it on the square root.
Okay.
But you'll see this cancel soon.
Okay.
Okay, so notice on the top you have a minus b times a plus b, right? This is your difference of squares. So remember, I feel like we talked about it, but I don't remember anymore. You remember the difference of squares, right?
Yes.
So we're going to jump from here to here, which shows you we're going to square this term, getting rid of the radical, and square the
Mhm.
constant.
Yeah.
So this is another approach for limits. Okay, so square the radical, square the constant. I'm not going to multiply the bottom because I'm trying to cancel this term. So I don't want to distribute it because then I can't cancel it without factoring it again. So we're going to have x minus 8 down here times x plus 8 plus 6. You guys still with me at this point?
Cancel out the square root with the 2.
Yeah. So right here, we'll get x plus 8 minus 36 over x minus 8 times square root x plus 8 plus 6. What is 8 minus 36? Let me double. Oops, I made a mistake. Do you see it? Yeah. The
Where?
two disappeared, right?
Yeah.
Sorry about that. There we go. Everything else is good. I don't know where I got that from. Anyways, no idea. 8 minus 36. What's that going to be?
Negative 28.
So now we got what we wanted, right? Since this is factored, I can cancel.
Yeah.
Now we got the limit as x approaches 28 of 1 over square root x plus 8 plus 6. Take the limit. We will have square root 28 plus 8 plus 6. 28 plus 8 is 36, right?
Mm-hmm.
Oh, what do we get?
6 plus 6, 1 over 12.
Yeah.
That will be the final answer. Right?
Yep. This is the limit
Oh,
of this weird function here as it approaches 28. Any questions on any of the steps here?
I just want to take a picture.
Okay.
I'm done.
All right, one moment. Sorry. No, I just got distracted. All right. So that's a conjugate. I think there's only one or two in there, most likely. You'll see one on your exam too.
Professor, did we do 2.2?
Yes. We did both in the same time last time.
Okay.
Because the first one was that intro to calculus was very short. And then we
Mhm.
did 2.2.
So we did it on the last class, right?
Yeah, I want to say we did, let me see how it blurs together, but 2.1 was a
Oh.
preview. 2.2 was when we were looking at the graphs.
Yeah, yeah.
So now we're here.
Okay.
Okay. Sorry, one moment. Did it not take it? There it goes. All right, number 10 is a rule from the book.
This is where the sin of x cancel out with the x, right?
I think we mentioned the squeeze theorem. No, I forget. Do you remember?
The what?
The squeeze theorem or sandwich theorem?
Yeah, I don't know what that is.
It's okay. Sine, okay. So basically it says when you have the limit of x approaching 0 of sine x over x, they will always be equal to 1. And we can prove it using the squeeze theorem. But and I told you last time it just takes time and we're not going to do that. So treat this kind of like a formula, and that's fine with me. So for the next question, righty, next question was number 10 on the homework. So they have x approaching 0 of sine x over 5x. I know they look, this is an S and that's a 5. I know they look the same. Sorry. So what you want to do is make it look like this. So you can kind of see, right, that this part right here is going to be 1, right? That makes sense?
Yes.
So what you do is use the properties of limits to factor out the 1/5. So you can factor out any constant in front and then take the limit. So now we have these match, right? That's the rule. So there's
Mhm.
if there was like a 3x in here, then you got to have a 3x down there. That
Oh,
makes sense.
yeah, they have to like cancel out with each other to make one.
Yeah, it's kind of. So basically, if they don't match, force it to match using algebra. Okay.
I mean, they have to be in match with each other.
Yeah. So the limit would become 1. So then you get only the 5th.
Yeah.
That makes sense.
Mhm.
Mm. Excuse me. All right. Number 11 is just a more complex algebra, trigonometry question. Do you guys remember your pre-cal?
I think so, because I took the pre-calc in summer, so I remember.
In the summer?
Yeah.
Oh, that's good. This is 5 thetas inside, cosine and tangent, divided by theta. And theta is approaching 0. Okay. So do your algebra to make it look like sine x over x, right? We want to use this. This is a property. Proved by the squeeze theorem. Okay. So what is tangent as a ratio? Do you remember?
Is it sine over cosine?
Yeah, it's going to be sine over cosine. So then what do you see? Yeah, exactly. And at least you're going to cancel, right? Now we're getting pretty close to. I need a new pen, it's running out. to that form, correct? What do I need in the bottom to make this work?
Is it sine of 5 theta at the top?
Yes,
So we have to make it match, right?
right.
I think we need 5 theta.
Yeah, we need a 5 here. So how do I introduce a 5 without breaking any rules?
Mm.
You multiply the theta on both sides?
Multiply by what?
We could multiply 5 by both sides.
There's only one side. We don't have two sides.
I mean bottom and
Yeah, we have to do top and bottom, right?
yeah.
Oops, I put another. I already put the 5 back in. Showing extra steps just to so it makes sense later. This would be 5 sine of 5 theta over 5 theta. Pull out the 5 because it's just in the way. Now we have sine of 5 theta over 5 theta. And I'll switch pins after this. This will be equal to 5
One.
times the 1, right?
Final answer would be 1 for 5, I mean.
That makes sense?
Yeah.
So this one was kind of like a, kind of like when, do you remember doing the identities? It's kind of like that.
Mhm.
The trig won't be too heavy in this class. Trig will come to hand. Well, the pre-cal and trig stuff won't come to haunt you until calculus 2. Cal 1, you can get away with just being good at algebra. You'll be fine. But yeah, I recommend brushing up on your trig at some point if you're going to Cal 2 for sure, or physics. So 13, 12, they're all similar. You just got to be creative with algebra or pre-cal. But that's pretty much it for 2.3. You have any questions on the problems we worked out?
I have a question on 2.2.
Okay, we'll save that for when we're finished because I'll leave some time at the end for questions and homework.
Okay, thank you.
And we can work on stuff together. All right, so that's 2.3. 2.4 is when they started doing the one-sided limits. So basically, let me write it down, I guess, first. 2.4, they talk about continuity. And one-sided limits. Yeah, exactly, Joshua. So basically, you just look on one side only, whatever side they're asking. We kind of already did, if you think about it. Let me find the definition that we're gonna need. Hmm. So before we do the examples, let me go over these formulas I wrote down earlier. Yeah, here we go. So this is a definition of continuity. All three of these need to be true. Otherwise, it is not continuous at that specific point. So let me write down all the digit definition stuff, which is in the book and the videos. I heard someone told me the videos weren't working. Is that true for everyone? No, I'll have to have to fix them. Yeah, the textbook will be inside the WebAssign. I'll try to find make a link. A removed video. What do you mean by removed, Elias? Oh, I see. Okay. Yeah, it's WebAssign. I'll add new videos as soon as possible. Sorry about that. Okay. I'll put two videos, one from the publisher and one from one of my friends who wrote her own notes, and then I'll be sending you the videos that we do together. So you'll have three different types as soon as I get to it. Okay. A function f is continuous at C when the following. Wait, I was going to change that again. Following conditions are met. Number one, f of C must be defined. In other words, you have to be able to plug in the number. Number two, the limit of the function f of x as x approaches C exists. And just to add a little more context to number two, in case you forgot, in order for the limit to exist, so if the limit from the left is equal to the limit from the right, so you put a little symbol here. There's like a plus. This is a minus. Looks like a really. So if they're equal, left side meaning the negative side, right side the positive, then the limit of f of x approaching C exists. Okay, that's what I mean by number two. Number three, the limit of f of x as x approaches C must equal the functional value. So whatever the limit is for number 2 has to be equal to number 1. The plugging the number in. Okay, so if they're not the same, you would say it does not exist, right? And I think earlier we had a removable example. Yeah, here it is. This is an example of removing discontinuity. Just let's go over it one more time, real quick. So f of x is equal to x minus 3 over x squared minus 9. So remember we had this cancel out earlier. Right? So when this happens, this is an example of a removable type. All right. Does that make sense?
Yes.
Yes.
Okay. So now let's get used to left and right limits. So look at number 1. So as we approach C, which is in this case, C is 7. If we approach from the plus side, meaning the right side, let me see, let's find an arrow. This might work. So we approach from, oops. From the right side, the y value is approaching the number 3, right?
Yes.
When we approach from the left, the y value is approaching 3. Oops. That makes sense. So from the right and the left, they're both going to be 3, right?
Yeah.
And if they're both the same, what does that mean?
It means the limit exists.
Yeah. So the limit is going to be 3. Now, is a function continuous at 7? So go through the three things we wrote down. Can we plug it in? Is there a hole here?
No,
So number one's good. If we plug it in, we get 3 right there. So F of
to what formula we plug in 7?
into F.
F of C.
This is F right here. So if you plug in C, which is 7, the output is 3, right?
I just don't understand where the formula is.
Well, they didn't give it to us.
We have to figure that out.
No. F is the line.
Mm-hmm.
So F of 7 is 3, right?
Okay. Okay,
F
got
of C is 3.
it. Okay, I got it now.
F of 0 would be 5, right?
Yeah. Yeah, I get it now.
I'm sorry, F of 5 would be 0. I think I said that backwards. Anyway, so the functional value is equal to the limit, right? So number 1 and number 3 are good, and obviously 2 is good because we said stop sharing. If you can plug it in other words, if F of C is defined, that is a requirement. So, and it is, we got a 3. The limit exists, we got a 3. If the limit is the same as a functional value, then 1, 2, and 3 are good. That means that yes, it is continuous. That's how you prove that it is continuous. You have to check off all 3. If one of them fails, then you just say no.
Professor, like, so the first condition is that f of c should be defined, right?
Mm-hmm.
So how do we know if it's not defined sometimes in some of the questions?
Either there's a hole there or you plug it in and get an error or some undefined value.
Oh, okay.
So if you can't plug it in or there's a hole there or both, it's undefined.
Okay. Thank you.
All right, let's look at the next one. Check this one out. This one looks like it's violating something, right? As we approach, so C in this case is -3. So as we approach from the right and the left, what number are we going to?
To -3? Or is it a whole? It would be undefined. I don't know.
Well, the limit exists, right? The limit is approaching something. It's approaching
The
approach
positive 3?
3, right?
Yeah.
So the right and left are the same, which means the limit exists. But you see there's a hole here, right?
Yeah.
But they end up, instead of using this value, they jump up here, like, oh, -3, 3 doesn't exist, but -3, 4 is replacing it. That way I don't violate the definition of a function.
Mhm.
There's no gaps. So now the question becomes, well, is it continuous though?
-3.
So number 1, can I plug in C? Is F of C defined?
F of C.
What is F of C?
f of c should be 3, right?
So go to, I'm sorry, go to -3, which is C. What X value, or sorry, what Y value do you get?
At -3, right?
Well, yeah. Plug in -3, what do you get? Where are we on the graph?
At +3?
No, there's a hole there, right?
Okay, it's not.
So
Oh, 4.
yeah, we're up here.
Yep, 4. I just didn't say the 4.
No, it's okay. So you see that the functional value is defined, which
Yeah.
is good. The limit exists, which is good. So number 1 and number 2 is okay, right? On our
Mhm.
definitions. Number 1 said f of c is defined, which it is. Number 2 said limit exists, which it does. We just showed it. Number 3 says that the limit is the same as a functional value. Are these the same?
No.
No, it's not. So not continuous. Does that make sense?
Yeah.
The 4 is right here. So this function is saying at -3, we have the point 4. They don't, because this one has a hole. So they said, you know what? For no reason, I'm going to put a hole here, but then put it up here. Using the, piecewise. Technically, this would be a piecewise function, right? They're just creating problems on purpose to make us think, is it violating one of the 3? And it is, right? Any other questions on number 2? Okay, let me know if you have one. Number 3, what is the limit as we approach 4? Which is right there. I got spaced out for a sec. From the right, where's that stupid arrow? There it is. As we approach 4 from the right, what y value are we approaching?
Probably -6 or
Look,
-5.
yeah, they kind of tell us right here, right? But it looks like it could be either if we kind of eyeball it.
Yeah.
From the left, what do we got? I don't know why it's cut
+5.
off, but yeah, it's gonna be 5 from the left, -5 from the right. If they are not the same, what does that mean for the actual limit?
It doesn't exist.
Yeah, exactly. D and E. I just put my D and E there. It's all good. Draw my happy little tree. All right, so number one's fine, right? What they didn't ask for it, but what is f of c? Oops.
5.
Yeah. And the limit. So number one's good, number two is not good, which means we can't even talk about 3. So no. Right?
Yeah.
Does that make sense? Does everyone see why this is not continuous at the point 4, x equal to 4? Is it making sense? Just let me know if whenever I make no sense. Just tell me. All right. This guy, they actually give us a function instead of graphs. So how would you approach this? You want the limit from the left. X approaching -4.
Yeah.
What would you do?
I mean, first we have to remove the square root from the bottom, I guess.
You could. I don't know if it would help though. I would just graph it and see what's happening on the left. That's it. Because over here we had graphs, now we don't. So let's find the graph. Right?
Or we could plug it in, -4.
Yeah, we should always try and plug it in, but you can see there's going to be a problem, right?
I guess.
Do you see it? But yeah, you're right. Always try to plug it in just in case. Oh, what was it again? Square root. The -16?
It was x over x squared minus 16 with the square root.
Okay. It looks like some weirdness is happening at 4 and -4, right? We have asymptotes, right?
Yeah.
Okay. What was the question again? What's happening at -4 from the left, the negative side? Okay. What's it doing as we approach from the left?
I think it's through infinity.
Yeah, it looks like negative infinity, right?
Yeah.
So in this case, we're not talking about infinite limits yet. I don't think it'll take it. So let's do D and E. Eventually we will talk about infinite limits. But for now, just say it does not exist because there's no actual finite value.
Yeah.
But you could write, and we will later, just say negative or positive infinity.
Mhm.
Okay. 5, do the same type of deal. Graph it and see what's going on. 6. They want to know where we are discontinuous. What do you guys think?
Somewhere around the open dot.
Yeah. Excuse me. Yeah, the top is a difference of squares. It's true. If I, it looks like if I plug in a -3, we're gonna have problems. Let's see if that's the issue. Right? So I can't plug it in. So that means we're not continuous there because it violates rule number 1. Although it is technically removable because it cancels, right? With the difference of squares.
Yeah.
But they didn't ask us about it. But this would be an example of removable discontinuity, but they didn't say anything. What we really do. All right, where are we not continuous here? What X value? Right, you see,
There is no graph, I can't guess it.
let's think about it, right? Is there a value you can't plug in?
I'm not sure.
Yeah, it's gonna be 0. If you plug in 0, you see the problem, right?
Yeah.
So that 0 is going to violate number 1. It's not defined. Undefined at 0.
Oh, and that makes it not continuous, right?
Yeah, it's not that makes it not continuous.
Oh,
No. If you plug it in 0, you get 7/0, which is division by 0. We can't do it. It doesn't cancel out, so you can't remove it. Anyway, that's pretty much it. Number 10, do the factoring like before, write down the values, and then choose which one is removable. You have any questions on 2.4? That's okay. All right, if you guys have homework from or questions from other sections, let me know. If you want to take a short break, feel free. Let's spend the next 30 minutes doing some problems. I have not checked my emails today. I'm going to check them in the morning. I can check it right now if you like. 1 second.
are we done for the lessons today?
Yeah, for the next 30 minutes, I want you to practice your homework.
Oh,
And then I'll take roll and we'll call it a day. Weird. Sorry, I got distracted. And Elise email. You're talking about the tutors, right?
Yeah, I went like I clicked the link to the Math World. Is that what it was called? And
Yeah.
then there was like another link in there for like the information on the tutors, and it like listed all the tutors. And I looked at like all of the available tutors, and like only one of them matched the names on the list. Like I wasn't sure if I was like looking at like the wrong thing, or
Hmm.
like I can like screen share if you want to see what I was like
Yeah, well,
seeing.
yeah, let's do that in just a moment. I'm trying to see if maybe I have an old link in there and I just didn't notice. One sec. Yes, it's fall 2023. So this is this. Let me share mine, I guess. This is what you were looking at, right?
Yes, and then like if you go like up just a little bit from there, you
Mhm.
can see there's on number 4, there's like all of the tutors can be found through Brandfrews, and you click here for the more information on the tutors, right? So then I clicked on that because like I didn't see like any of the tutors listed on like that main page. So I
Mhm.
clicked on that, and then it took you to like another page, and then it showed you like all the different tutors for like all the different classes, and like their hours and like contacts and like everything. And like I looked at all of them, and there was only like one that was named Shara, and like none of the other ones.
Okay, well let's see here real quick. Yeah, it looks. Hold on, that's weird.
That just sends you to like Zoom. That's a Zoom link.
You want to go in person or is it via Zoom?
No, I don't do it in person at all. I'm 100% online.
Oh, okay.
Yeah.
Yeah, there should be Zoom links in here. Let me figure this out. It looks different than it used to be, but it appears 14. Yeah, so when I go in person to tutor, I think I'm going to be doing Thursdays before this class starts. They have people at the desk waiting for people to log in via Zoom. So I think you click this link between 8 and 7 and just tell them what course you want to go over, what topics.
Oh.
I think that's how it works. Over here, I think it's a different tutoring lab at the TNT Center. And then we also have the Brainfuse, which is like a separate private tutoring that you can like it's 24/7.
I was looking at the wrong tutoring center.
Yeah, TNT is a different one.
Oh, okay. Okay.
I don't know
that
if they
makes
have. I don't know if they do Zoom or not. I'm not as familiar with them.
So I'll just have to like go on their little Zoom tomorrow and ask them.
Yeah,
Okay.
I think. Let me see. Usually they have like a schedule of what time they can do certain topics or certain people, but I don't see that this time around.
Yeah, I'm just like I'm behind on like a lot of the like
Hmm.
the orientation stuff, especially because like normally I'm like on top of things, but I had like family over this weekend and our house was like a mess. So my mom had me like cleaning for like literally hours on end every single day. So I didn't have like a lot of time to like work on school stuff. So now I'm like kind of cramming.
Yeah, you don't want to
Yeah.
behind
And I
math.
don't
Math
have
kind of falls
my
on you.
like actual assignments unlocked yet because like you can't like unlock the assignments until you finish the orientation. So I'm trying to finish that. So like a lot of the like homework stuff like 2.1, I haven't even started.
Okay.
So
Yeah,
like
try to hit it
that's
hard this weekend so you can.
yeah,
Right now
I'm
we're still early.
planning to.
It's not too bad yet.
Yeah. like I'm really close to being done with that. I think that this is like I only have like 1 or 2 more things left to do on the orientation, and then I'll be good to go. I just like
Yeah, I
know.
still need to grade the orientation for a few people. Although I think it closed yesterday, right? The orientation.
Some of them did.
Okay.
I think that some of the orientation stuff is due on the 11th, the same day that some of the homeworks are due.
Mhm.
But then yeah, some of it closed just a day or 2 ago.
Did you get all those done?
Yes.
Okay.
Okay, well, that was all I was gonna ask. So
Okay.
I will, well, since I am kind of incapacitated right now, I will wait until in the morning to call them so I can finish that little thing. And
Okay. Yeah, let me know if you
Go.
need anything, and yeah, just
thank
Try
you,
to meet
and
as well.
have a good night and a good weekend.
Okay. Have a good night.
Hi, sir, I had a question.
What's up?
So I think it might be a pre-cal thing.
Mhm.
On 2.2, question number 4, it brought up e to the x, and like I vaguely remember it, but
Mhm.
I don't remember it.
You
if
want to?
that
Do you have the
makes-
question open? If you
What
want
was
to,
that?
do you have the question open? If you want to share your screen, maybe we can work through it if you like.